Hey guys, I want to go through this Friday's exponents quiz with you. There's a lot of stuff on here. I'm going to go through the whole test question by question. You can see the questions that are going to be on there. So again, fast forward it, rewind it, pause it, go through the questions that you need help with, and I'm going to get started right away. All right, so this first question here, number one, obviously the problem with this is the radical. You're trying to solve for x, but the radical being there is going to get in the way. So obviously I want to square both sides to get rid of this radical, but I cannot square it now. This x needs to be moved to the other side. If I were to square right now, I'd need to square the entire side, which is going to get to become ugly. So your very first move here is to add the x to both sides of the equation, meaning that I end up with x plus 2 on this side of the equation. 2x plus 3 stays in place, and now I have this. Now what I've done is I've isolated the radical, and now by squaring both sides, I can knock off that radical. So when I raise this to the second power and also this side to the second power, I end up with just 2x plus 3 over here. And now on this one, the mistake that I've seen, a common mistake, is a lot of you guys are saying something like this, which is not true. I understand what you're doing. You're doing x squared and you're doing 2 squared, but that's not true. That's not what this ends up being. When something's raised to the second power, it means that you have to write it twice. And sometimes we get so good at that that we forget that that's actually what's taking place, but that's really what's happening here, okay? And now when you see it written out, it becomes more obvious that this is a distributive property issue. You have to distribute the x to both pieces. When you're done with that, you distribute the 2 to both pieces, and you end up with that result. So it ends up looking like this. Um, at this point, again, I'm going to collect like terms so I can get the x's alone. So I'm going to move the 2x and the 3 over to the right-hand side. I'll end up with 0 equals x squared plus 2x and plus 1. So take a look at that and make sure that makes sense to you. What I did was I subtracted 2x and subtracted 3 on both sides, and I ended up with that. Now that my equation equals 0, I can factor it. There's an equal sign in there. X, let's go with 1 and 1, plus and plus. So I end up with two answers, but they are both the same thing. I end up with x equals -1 and also x equals -1. Okay. Now the thing is, so that's all good. You did the answers correctly, did the process correctly, and all that stuff. The one thing to remember about these types of questions is that when your problem starts off with a radical in it, then that equation is susceptible to having extraneous solutions. What I mean is that you have to go back and check this answer and see if it actually works in the original problem. Now, the original problem said 2x plus 3 inside of a square root minus x equals 2. And what I mean now that you've solved and said that x equals -1, we're going to replace the x's with -1s and see if this in fact turns out to be true. So at this point, I would pause the video and try to work this out right here. Do this here, this left-hand side here, and see if it in fact comes out to be 2. And if it does, that means that your -1 works. So as you work through this, you should have come up with this. This becomes radical 1. Now over here, you've got a double negative, making it a plus 1. So you end up with 1 plus 1, oops, 1 plus 1, which does in fact equal 2. So you get 2 equals 2. So you know that this answer of yours, it does in fact work. Sometimes you'll find that these two, if you got, for example, 12 equals 2 or something like that, then this -1 would have been what's called an extraneous solution. You got it legitimately, but when you plug it back in, it actually doesn't work. And that will happen from time to time. Okay, and the second question, this was a very, very commonly missed question, but we've seen this question 1,000 times. You're going to continue to see it. The domain here, state the domain. I'm asking you what x values work in this equation. Okay, so what am I allowed to plug in for x? That's kind of what we're being asked here. Um, the problem has a radical in it. So, for example, if I were to put in the number 1, for example, let's just say x equals 1, you would end up with 3 minus 8 times 1 inside of a radical, which would be 3 minus 8 inside of a radical, which is the square root of -5. Now, you can try that in the calculator, and what you're going to find is that the calculator is going to give you an error in doing that, okay? So you can see that there are certain numbers in here that are not going to work plugging in for x. So the question that they're asking here is, what can I use for x? What does work in this equation? And what it breaks down to here is that when you're doing a problem like this, a function, where you have a radical, like so, y equals radical, okay? The inside of the radical needs to be something positive, okay? Whatever you plug in for x, by the time you resolve what's inside that radical, that needs to become something positive. So one of the ways that I've shown you guys to deal with this is to take what's inside that radical and make sure that it is positive. That's what you need. You need to solve for x in such a way that this result turns out to be positive. Now, you can't really set it up exactly like this because we need a value on that right-hand side. So what I'm going to do is, instead of saying equals plus sign, I'm going to say greater than or equal to 0 because that's basically the way that you express things that are positive, things that are greater than 0, right? So now when I solve for x, I got negative 8x is greater than or equal to negative 3. I'll divide now by negative 8, and I'll flip the sign, flip the arrow in doing so when you divide by a negative, and I'm going to get 3/8. That's a 3 up top. Okay, so what I have now found is that the numbers that work in this equation, 0 is here, 1 is here, and let's just put 3/8 about there somewhere. I need numbers that are from here down. And if you pick any number out here, for example, -1, if you pick a number like, from this category, then you will find that you will get some answer that actually works. On the other hand, if you pick something like over here, like we just did a moment ago, you'll find that the calculator will tell you it doesn't work. It'll give you an error, okay? Now I have stated the domain of this function. Now I'm telling you the only values for x that you can use are ones that are less than or equal to 3/8. Okay, next question. I obviously have to start with the substitution here. It says that n, it wants to do n over m. All right, so the n is a to the fifth with a radical on it, and the m on the bottom is just a. It tells me that here and here. So really, they just want me to simplify this expression. All right, now what I'm going to do here is, since the top has a radical and the bottom doesn't, I'm not allowed to just subtract the 5 and the 1. I can't do that. So what I'll try to do is break down this top because I have a radical of a to the fifth. So what I'm going to do is I'm going to break this into the radical of a to the fourth and the radical of just a to the first. Okay, the bottom is going to remain unchanged. The reason I did that is because now I can take half of this a to the fourth thing and end up with a squared there, a squared, and then this stays the way that it was. Okay, now I have that. And now the two outside pieces, meaning this one and here, I want to change colors on that. This one is going to cancel, one of these guys and just leave you with a single a, and that is the answer to the problem. It's going to be a radical a is your final result. Okay, so again, go back and look at that and see the way this took place. What had to occur to you is this very first step, breaking down the a to the fifth, getting yourself to this step here, and then reducing those a's out front. Now remember, the a squared really means a times a, and we had an a in the bottom, and that's the reason that we were able to reduce one of them, leaving you just single a, and that's how that happened. Okay, so a problem like number 6 here is a tricky problem, and you may find, 3 different people will tell you 3 different ways of doing these problems, and I'm sure they're all legitimate, so, find the way that best works, for you. The way that I've explained it is the first thing that I'm going to deal with is this negative sign, okay? And that negative sign is going to put this entire parenthesis now in the denominator of a fraction, all right? The 2/3 itself won't change. Nothing inside of the parentheses will change either, but it just picks up that package, that parenthesis package, and just moves it to the denominator. And that's the first thing that I would deal with, all right? The next thing then I would deal with is this 2/3. Okay, now this 2/3 exponent is going to apply to everything inside of this parenthesis. So the 1 stays up top. Now, 2/3 is a tricky thing, but you certainly could plug it into the calculator if you're comfortable doing that. 27 raised to the 2/3 power, and it will give you the answer. If you want to isolate that, 27 to the 2/3 power, one way of dealing with that is to consider 27 to the 1/3 power, which hopefully you realize that that means the cubed root of 27, which is 3. So this is really just 3 now, okay? And you have a squared waiting outside. So I've separated that fraction. So now I still have this squared, and the answer to this thing is going to become 9. Okay, so anyway, if you type into the calculator 27 to the 2/3 power, you're going to find that this ends up being 9. As far as the A, Well, as far as the a goes, I have a is raised to the third power, and then it is raised to the two-thirds power. So remember, in this situation, I'm going to multiply my exponents. So I'm going to end up with a, and when I multiply these two fractions, I've got negative 6 over 3. Remember, I'm doing top to top, bottom to bottom. So that all becomes a big negative 2. So that's what happens to my a. It's a to the negative second power. Now, again, I'm following this thing very literally, just dealing with what's in front of me. And yes, I'm going to deal with that negative sign on the a in just a moment. But let me just finish off with these b's since I'm working on it, okay? I got b to the 12th, and I've got that raised to the two-thirds power. I'm going to do the same thing. I'm multiplying my exponents. So this ends up being b to the 24 over 3. Again, I'm doing 12 times a 2, 1 times a 3, and that ends up being b to the 8th power. So that's what I'm going to put in this position, b to the 8th power. And now I'm mostly done with this. The last thing, though, is that I have to move this a up to the top because it has a negative exponent on it. So the final answer should be a squared over 9b to the 8th. And that's how you do number 6. Moving on to number 7, the fractions here are the things that will probably throw you off a little bit. But remember, in a similar question, if I just gave you, x to the 10th over x to the 7th, I think everybody would end up with x to the 3rd. But the reason you're getting that is because you're doing 10 minus 7, and that's how you're getting x to the 3rd. Okay? So the point is that on this question, it's the same situation. I have x raised to something over x raised to something. I'm going to subtract the two somethings. So in this case, I've got x to the 5 fourths, stop moving around, 5 fourths, minus 3 fourths. So again, similarly, I'm just simply subtracting exponents. And that will give me x to the 2 fourths. Okay, now that can be reduced a little bit. I'm going to jump down here. Okay, I have x to the 2 fourths, remember. All right, and that of course reduces to x to the 1/2 power, which is the answer to the question. You're welcome to leave it like that. Another way of writing this, of course, you should recognize that that means this, but either one of these two answers are acceptable. The point here is you are subtracting exponents. It looks like I jumped around a little bit, probably to save space, but it looks like I'm back here on number 4 and 5, so let's get those out of the way. In this question, I am first going to deal with this situation. Okay, I have a parentheses squared, so I'm going to deal with that first. Um, the rest of it will stay in place for the moment. And when I have these x to the 5th raised to the 2nd, I multiply it, giving me x to the 10th. And this is going to be y to the negative 12th. Oops. Okay, so now I have that. At this point, you have a couple of options as to how you want to deal with this. Not to do too much at once, I'm going to keep the 3 and 12 in place so we don't lose track of them. And I'm just going to deal with the top and saying that the x times the x gives me x to the 11th power. And x to the 9th power stays where it was. Okay, now I have a funny thing going on with the y's. Since the y has a negative exponent, this y to the 12th will drop down to the bottom. Okay, now that's its own thing. That does not force this y up top. It doesn't. But as it turns out, this y also has a negative exponent, its own negative exponent, and that moves it to the top. So that's the way this thing ends up. So the y's moved, the 12 went down, the 2 went up, but it wasn't just a flip. They each individually moved for their own negative exponents. Now that I've got all the negative exponents reconciled, I will now reduce the fraction. I'll do number to number, x to x, y to y. I'm sorry, I think I already, let me go back to that. I said I wasn't going to do the 12 thing, but I did. Sorry, you should have known that was supposed to be a 12, right? That was my fault. So now I will, in fact, reduce it and give you 1/4. That's what I was doing in my head as I was speaking. That's what happens to the 3 over 12. Okay, so as far as x's, I am going to subtract those exponents. So 11 take away 9 gives me 2. Those 2 leftovers will be up top. As far as the y's, I will also subtract them. I'm going to get y to the 10th on the bottom, and that's the answer. And now let's do number 5. Again, these exponent questions, there's a number of different ways you can do them. This is one category where the order uh, can be, I can do it one way, you can do another way, and we'll still get the same answer. But I'll tell you what occurs to me on number 5. What occurs to me is that taking the square root of all these pieces right now is not going to be an easy task. So I will skip that part and let's deal with the inside only. And I'll deal with the square root later. Okay, so the square root will remain. I'll deal with it later. And for the moment, let me see if I can simplify what's inside of this radical. As far as numbers go, I end up with 25 on the bottom. The 2 becomes a 1, the 50 becomes the 25. As far as x's go, this negative sign is going to move this x to the 7th up top, which makes it look something like that. Ultimately, I'm going to have x to the 8th power in a moment. And the y's, well, I'm going to subtract those. So I end up with that. Okay. Now I've reduced everything I can inside the radical, and I think that now taking the square root of these pieces isn't really so bad. When I take the square root of the top, I end up taking half the exponent, giving me x to the 4th. When I do the bottom, I actually take the square root of 25, meaning 5 times 5. And when I take the square root of this, what times what will give me y to the 8th? Well, y to the 4th times y to the 4th will give me y to the 8th. And that's the answer to the question. That's number 5. So remember, I go through things in these videos rather quickly because I don't want to, waste your time. I know it's a long video to watch. So again, fast forward and pause it as you need. Number 8 is different from numbers 9 and 10. Okay. So I'll deal with number 8 first. And there's a lot going on in this problem. So at first, I'm just going to deal with this radical. Okay. And there's enough going on with that radical to be its own question. So let's deal with that. Now, as far as the a to the 8th, I'm going to leave that outside and not deal with that for a little while. And I'm just going to deal with taking this square root. Okay. Now, the point I'm going to try to make here is that in this radical, I have 3 separate pieces that are in fact multiplied to each other, which means that I'm allowed to separate these into 3 separate radicals. And again, that's because they're multiplied to each other. If these were added to each other, as they are here, I cannot do 3 separate radicals. I want to point that out right now. This is not the case. All right, this doesn't work. You're not allowed to do that. Okay, and that's because these are connected through plus signs. Back here on number 8, these 3 pieces, the 192, the A, and the B, are connected through multiplication, and that allows me to separate into what I've written here in red. Okay, so as far as the 192, you're looking for perfect squares that go into 192. So I found that 64 works, and the reason I use that is because now the square root of 64 is just 8. Here's my radical 3. The 192 is now broken down. As far as the A's go, well, there's really nothing that can be done about the A's. He's going to stay just the way he is, but the B, on the other hand, he becomes b to the 3rd. Okay, and I think we've done a few of these at this point. Hopefully you realize that what just happened is that I had this, and the square root is really a 1/2 exponent, and that's the reason I ended up here. And now just to clean up what I've done here, written in red, is that everything that has gotten outside the radical, I'm going to put out front, and everything that remains inside of a radical, I'm going to put into one big radical. Okay, but don't forget that all along we had this a to the 8th b sitting outside, and now it's time to deal with that. That was out here. Okay, so now finally I can actually multiply this, the green to the red, number to number, a to a, b to b, radical to radical. So as far as numbers go, you end up with just 8. As far as b's go, I'm sorry, a's, I just get a to the 8th power, and b times b is going to give me b to the 4th power, and the radical is nobody else for him to go with, so that is the result of the first part of the equation. Okay, so now let's work on this second radical over here. All right. Similarly, I'm going to leave the 2a out front, and I'm going to break the rest of the radical down into 3 separates. So 75, a to the 15th, and b to the 8th. And that leaves me there. Okay, so I can concentrate on each one of them individually. As far as the 75, I'm looking for 2 perfect squares that are going to go into there. I think 25 and 3 works pretty well. That would give me 5 radical 3. The next piece I'm going to work on here is the b to the 8th power. That's kind of the easier of the two because, again, this is a square root. So I'm going to divide the 8 by 2, give me b to the 4th power. Okay. Now, the tricky part here is the a, this guy here. All right. And the reason I say that it's a tricky one because I want to divide it by 2, but 15 divided by 2 turns out to be, something 0.5, right? So we don't want that. So what I'm going to do here, and there's a couple of ways of dealing with this, but the way I'm going to show you here is I'm going to say this is going to be, I'm going to break the 15 into 14 and 1. All right, because when you multiply those two together, you do in fact get 15, right? So my radical a to the 15th has now become two separate radicals, a to the 14th and a to the 1st. The reason I chose that combination is because this gives me a to the 7th, right? I wanted to break it into something even, right? So I just broke one little piece off the 15 to make it an even number, 14 and 1. As far as the radical a, well, there's nothing I can do with it. He just ends up, staying radical a, okay? And all of this, remember, I'm going to clean it up in a second, but don't forget about your 2a out front. He's still out there. That's a 2a. Okay, so I've cleaned up the those pieces now. Again, everything that was not inside of a radical, I put out front. Everything that was inside the radical, I put um, inside one big radical. So finally now, when I multiply these two pieces together, I'm going to go, green to red. I'm going to do 10a to the 8th, and there's no other b's, so I'll say that's b to the 4th, and there's no other radicals, so I'll keep it as radical 3a. And that's what happens to that radical. All right. And now remember that we still have, these were two separate pieces. I've done them individually. Let's put them next to each other and make sure that we can, that we're done with the problem, in fact. And now when we look at these two, we have to decide if they are like terms or not. Well, what I see on the left-hand side is if we got 8 of these things, I'm talking about 8, a to the 8th, b to the 4th, radical 3a's. I've got 8 of those. On the right-hand side, I've got 10 of these things. And these things are a to the 8th, b to the 4th, radical 3a's. In fact, it turns out that they're both the same things. I've got 8 of these plus 10 more of the same things. So altogether, I've got 18 of these things. I'm just simply adding these things together. So I'm adding like terms. So the like terms themselves don't change. That's the answer to the question. As it turns out, I have 8 of them plus 10 of them gives me 18 of them. They don't change. That is the answer. Okay, so getting to these last two, I pointed out a moment ago that this is different from the last problem, okay? And it's different because, number 9 here, these are three terms that are added to each other. This is a trinomial, all right? And I cannot separate them into three separate radicals. If it had said something like, 9x squared, for example, then yes, you can do the square root of 9 and the square root of x squared, and you can treat them separately. But that's because the 9 and the x squared were multiplied to each other. In the case that we're actually dealing with, that's not what's happening. The um, the three terms are added to each other, so I cannot separate them into three separate radicals. You can only break this into two separate radicals if you have two things that are multiplied to each other. So what I'm going to do here is, the only thing I can do is I can try to factor the inside. Okay, the radical will remain in place, but it turns out that I can factor this thing into x plus 3 and x plus 3. Now when you look at that, since they're identical, I can write this as x plus 3 squared. And now, when you look at it, you have a squared and a square root, which cancel each other out. And that's the answer. On number 10, I have the same deal going on. They are two terms that are added to each other. I cannot break this into two separate radicals. So I'll try to factor it. So let's see what I can do with that. If I do a GCF on this, okay, the radical stays in place, I can pull out a 9. In terms of a's, I can pull out a to the 6th, and I can pull out a b to the 2nd. Okay, if I do a GCF pullout, I end up with this out front, and I'll have two pieces inside this parenthesis. I think that will be a 2a. When you multiply here to here, you should get 18 a to the 7th b squared, and that's 2a. And when I multiply this to this, I'm going to end up saying that that should be just a b, I believe. That's it. And again, when you multiply this to this, you should end up with this. And in fact, I just did it in my head, and it does work, so looking good so far. Okay, so now I have two pieces that are multiplied to each other. I've got this piece, and they are multiplied to each other, which means that yes, I can separate them into separate radicals. 9a to the 6th b squared, and a radical of 2a plus b. Now, the left-hand side, this radical turns out not so bad. I got 3. Square root of 9 is 3. A to the 6 becomes a to the third, right? I took half of 6. And b to the second becomes b to the first. So it ends up just looking like this. On this right-hand side, look, I've got 2 separate pieces that, again, are added to each other. So I can't split that radical in any way. The only thing I can do is, well, just leave it the way it is. Nothing else can reduce there. This just stays 2a plus b. And that is the final answer. All right, so look, guys, I hope that that helped make your corrections. And yeah, I think you guys are doing a good job. But yeah, this is every little bit getting better helps. And I think if you can get all this down, there's a lot on this test. It's pretty heavy stuff. And if you got this down, I think you're doing a great job. All right, good luck. See you later.